Tomorrow's quiz covers section 6.1 to 6.3. There are 10 questions on the quiz. And again, always remember, use your warm-ups, use your homework, use your notes, and in addition, use the quiz review. Honestly, majority of the questions look like the warm-ups that I'm about to go over. Now, you will have sometimes, always, or never questions, and where you're going to probably benefit from studying for those. If you remember the last slide of the 6.3 notes, that had a nice summary of all of the different segments that were in the triangles, as well as their points of concurrency, and it gave examples. And then it also had properties, which described what these different segments did. So make sure you know all about perpendicular bisectors, angle bisectors, medians, altitudes. Know those 4 things. Know all of their points of concurrency and what they do. And that's where the sometimes, always, or never questions are going to be based on. You will also have something that's not in the warm-up. It's that wonderful long problem where you have to come up with the equation that's perpendicular. So same thing that we did in chapter 3, in 3.5. We're going to do it again now, but we're going to do it on the quiz. When we did it in chapter 3, I told you I would not put it on the test, but now it's going to show up on your quiz. So make sure you understand that whole process of first finding the midpoint, then finding the slope, then turning it into opposite reciprocal, then plugging it into y equals mx plus b, get the appropriate y-intercept, and then plug everything back into y equals mx plus b. So you will have to do that on the quiz tomorrow. It was not put in the warm-up, but it was in the notes, and it was on your homework. So that's what we're gonna, that's basically your quiz for tomorrow. So I'm gonna go through the 3 warm-ups here, and this will be a nice little review. And then I've also included a picture of the screenshot of those 6.3 notes. And then if you want to see anything worked out from the homework that was due today, or the review that was on your to-do list, but you don't need to turn it in, I'll work out any questions you want to see after we work out all these warm-ups. Any questions so far? All right, so let's go ahead and let's do the warm-ups, because again, the quiz looks very much like a lot of these problems. So in exercises 1 and 2, both of them are asking us to find the length of AB. So again, whenever you're taking any of the tests or quizzes in this class, always make sure you pay attention to what it's asking for. We have to find X first, but then we have to plug it back in on numbers 1 and 2. So this one, we're going to be applying the perpendicular bisector. So I know that if a point is on that perpendicular bisector, which I can tell that this segment right here is the perpendicular bisector because I've got a right angle and it's split segment AC into 2 congruent parts. So because of that, I know that point B, which is on that perpendicular bisector, is going to be equally distant from point A as it is from point C. So in order to solve to find X, I'm going to set BC equal to AB. So 4X minus 7 is equal to 3X plus 1. Doesn't matter the order you write this down. You're just setting them equal to each other. I'm going to subtract 3X. And then I'm going to add 7. And my X value is 8. But it didn't ask for X. It asked me to find the length of AB. And AB is the 3X plus 1. So AB, 3X plus 1. So 3 times 8 plus 1. And I get 24 plus 1. So the length of AB is 25. Now, technically, I could have plugged it into BC because these are congruent segments. However, I just plugged it back into the one that they asked for. I'm doing exactly the same thing on number 2. The picture is just flipped upside down. But again, this is still the perpendicular bisector. So I still know that point B is equidistant from the endpoints A and C. So again, I'm going to set the 2 expressions equal to each other. 7x equals 5x plus 7. Subtract 5. And 2x equals 7. Divide by 2. And x equals 7 over 2. So you can actually keep it 7 over 2 and work with it as a fraction. You could also make it a mixed number or a decimal. However, we're not done yet because it asks to find AB, not x. So now I need to figure out where AB is. AB is right here. So AB is equal to 7x. I'm going to work with it as a fraction. I'm going to put it in here as 7 over 2. I can add a 1 to the denominator of the 7. And now I'm just going to multiply straight across. Nothing simplifies. And I get 49 over 2. So the length of AB, you can leave it improper if you choose, or you can make it a mixed number, or I would also accept the decimal version. So again, tomorrow on the quiz, anything goes. You can have decimals and fractions as your answers. Let's do now, this was the perpendicular bisector. Now 3 and 4, we're going to be doing the angle bisector. Also in 6.1, we learned about angle bisectors. So we learned that when an angle has been bisected, any point on that angle bisector is equidistant from the sides of the angle. So because I have two equidistant segments here, and I can see that their distances because they have this little right angle, I know that this angle has been bisected. So I'm going to set 3x plus 4 equal to 4x minus 8. So I'm going to do 4x minus 8 equals 3x plus 4. I'm going to subtract the 3x. X minus 8 equals 4. Add the 8. And x equals 12. This one only asked to find x. It didn't ask us to find the angle measure, so I stop right here. If it would have asked me to find the measure of that angle, then I would have plugged in x. I would have plugged in a 12 for x. Now the next one, this one's a little different, but if you remember, if your angle has been bisected, like this one is right here, then I know that any point on that angle bisector is equidistant from the sides of the angle. And remember, the distance is always indicated by the little right angle here. So again, just like we talked about when we talked about the distance from a point to a line back in chapter 3, again, if you've got your banks of the river and you want to swim across this river, we always want to go the perpendicular distance across, and that's how distance is always indicated, by the little right angle. So this tells me that since I know this was a distance, I'm going to set 4x plus 10 equal to 90 degrees. Subtract 10. 4x equals 80. Divide by 4, and x equals 20. I'm done. If I were to plug it back in, that I should be getting 90 for that value. If I don't, I've done something wrong. Now in section 6.2, this is where we started talking about the points of concurrency. So in this diagram, the perpendicular bisectors of triangle ABC are all meeting at point G. Here's where we need to apply our knowledge, and we need to know what is the point of concurrency called when all three perpendicular bisectors meet there. And we know that point G is called the circumcenter. So again, you should know that the perpendicular bisectors, their point of concurrency is the circumcenter. So let me go ahead and highlight here. So I'm going to highlight all of my perpendicular bisectors in blue. And I learned that from this point of concurrency, I can draw a segment that is equidistant to each of the vertices. So all of the red lines are the equal distance segments from that point of concurrency. So if they've already labeled BG as 7, then I also know GC is 7, and I also know that AG is 7. So that was the second part here, GC. They wanted us to find the length of it, and that's 7. And the other thing they asked me to find is the length of EC. Well, if these blue lines are perpendicular bisectors, I know that it is split this side over here. CE is congruent to BE because the blue line is the perpendicular bisector, and it's splitting BC into two congruent pieces. So if BE is 5, so is EC. So be able to apply all of this definitions and theorems and be able to find missing pieces from your figures. Also in 6.2, we learned about the point of concurrency of the angle bisectors, and that'll be the next example. All right. So in this diagram, the angle bisectors of triangle XYZ are all meeting at point D. What is point D called? Well, we learned that the point of concurrency of the angle bisectors is called the incenter. And again, let me highlight the angle bisectors in blue. So these are all the blue ones are angle bisectors. And I know from my theorem that from this point of concurrency, this incenter, I can draw segments to each of the sides that are equidistant. So the equidistant segments, and again, they're indicated by right angles because they're a distance, these are all going to be congruent segments. So in this problem, they're telling me the length of one of them, AD here, is equal to 10. So if AD equals 10, then I know DB equals 10 as well as DC. But they were only asking for DB. So the measurement of DB, because it's the equidistant segment from that incenter, has a length of 10. So for 6.3, here we learned about the centroid, which is the point of concurrency of the medians. So in this, it's got 3 different things, and each time we're going to change up what they're asking. So first one, it says if BG equals 9, find BF. So let me go ahead and find out where BG is. BG is right here. And they told me that that has a length of 9. In this one, this is where the median is broken up into a 2/3 section and a 1/3 section. So I know that the length of BF, if I take that length and multiply it by 2/3, it gives me the length of BG. So what I can do is I could set up an equation here. Let me just do it down here so I have plenty of room. So for number 1, I can set up an equation and say that BG is equal to 2/3 the length of the whole median. Because again, remember, the median, the point where they all meet is called the centroid. So I learned that the BG length is 2/3, and then GF is the 1/3 portion of the median. So now I'm going to replace what was given to me. They gave me BG is 9. And now I'm solving for the whole thing, BF. I'm going to multiply both sides by the reciprocal because I'm dividing by 2/3. So I'm going to multiply this side by 3/2, which gets all this to cancel. So I'm just left with BF now. And whatever I put on one side, I got to put on the other. And this will not be able to be simplified, so I just multiply it as is. So the length of BF is 27/2. You can leave it like that, or you can also divide it, and it becomes 13.5 or 13.5. Now, when you're doing this on the quiz tomorrow, I don't need to see the red equation I wrote. It just helps me to see the relationship of the different pieces. You can just show me your work and what you multiplied or divided. Anybody good on that? So you do have to show work to back up your calculations, but you don't have to write an equation like I did. It helps me though. All right, number 2. It's asking me to find the length of AD. Now, AD is not a median. Yes. Are we able to go? Okay, so it's asking me to find the length of AD. AD is not a part of the median. It's a side of the triangle. But if you recall, these are all medians here. So let me go ahead and go over them. So all these are medians, all these green things. These are all medians. And remember, the median starts at the vertex, and then it goes over to the midpoint of the opposite side. So over here, this point D that's right here is a midpoint. So if they gave me that BD is 12, then I know since D is the midpoint, AD is also 12. And then the last part on this slide, they're giving me the length of CD, which is the whole thing here. Let me go over it in purple. So now I'm talking CD here, and they gave me that entire length, it's 27. They want me to find GC, which is the 2/3 part. Remember, the 2/3 part goes from the vertex to the centroid. The 1/3 portion of it goes from the centroid to the side. So I'm going to set this up as 2/3 of the length of CD is equal to GC. I'm given CD, so 2/3 times 27 over 1. I'm just going to add a 1 to the denominator so I can multiply these fractions. I'm going to simplify diagonally here. I'm going to change my 3. I'm going to make it a 1, and I'm going to make my 27 a 9. And now I can multiply what remains. 2 times 9 is 18. 1 times 1 is 1. So the length of GC is 18. And then the last 2 problems in the warm-ups. Last 2. It wants me to find the centroid of ABC. Now, I highly recommend that you use the shortcut I showed you by just taking all of the x values of the vertices, add them and divide by 3, and take all the y's, add them and divide by 3. Because if you graph it, now if I were to ask you to draw in the medians, then you'd have to show all the work. However, I highly recommend that you find the centroid by just taking the x values, add them, divide by 3, take the y values, add them, divide by 3. Because if your centroid ends up in the middle of a box, you're not going to know, unless your graph has got like halves and quarters, you're not going to know precisely the decimal it's going to be without doing my shortcut. So let me show you the shortcut, and then I'm going to show you the long way in case I were to have asked you to graph them. So the shortcut, first thing we need to do, notice this time they didn't list out the order pairs, they just graphed the triangle. So the first thing I need to do is figure out the order pairs for A, B, and C. So the order pair for A is going to be -3, +1. Order pair for B is 1, 5. Order pair for C is 5, -3. The easiest way to find the centroid is I'm going to take all of my x values, I'm going to add them up. So I'm going to add -3 plus 1 plus 5 divide by 3. Then I'm going to take all of my y's, I'm going to add them. So I'm going to add 1 plus 5 plus -3 divide by 3. This ends up giving me 3 over 3. This one gives me 3 over 3. So my centroid is going to be located at the order pair 1, 1. So on the quiz tomorrow or on the test, I highly recommend you find the centroid using this method. Now, if I ask you to graph them, graph in the medians, the proper way is to find the midpoint of each one of the sides. So I'm going to go ahead and do that calculation. So I'm going to take and find the midpoint of AB. And again, I'm using my coordinates. So I'm going to be doing -3 plus 1 divide by 2, 1 plus 5 divide by 2, -2 over 2, and then 6 over 2. And the midpoint of AB is -1, +3. I'm going to go ahead and graph that in here. And then I'm going to draw in the median. And now I'm going to do the next midpoint. I'm going to find the midpoint of BC. So for BC, I'm going to add 1 plus 5 divide by 2, 5 plus -3 divide by 2, 6 over 2, 2 over 2, order pair 3, 1. So let me graph that one. Draw in the median. Last midpoint is AC. Let me come over here to the side. So again, -3 plus 5 divide by 2, 1 plus -3 divide by 2, 2 over 2, -2 over 2, 1 comma -1 is the midpoint over here. Draw in the median. And again, just like we did when we calculated it without graphing it, my centroid is right here, the order pair 1, 1. So you can also do it by finding the midpoints. Again, the median is formed by going out of the vertex to the midpoint and then finding the point of concurrency. And then the last one, which type of triangle has its orthocenter on the triangle? And it's going to be a right triangle. So again, I highly recommend finding the centroid. Just add the x's, divide by 3, add the y's, divide by 3, especially if you try to graph it. And if your point of concurrency is like halfway in the box, you're not going to know if it's if it's 1/4 or if it's 1/2. But by doing the calculation, it'll give you the precise answer. And then the last thing, I just took a screenshot. This was the last slide of the 6.3 notes. And again, it's got all 4 segments. It also shows their point of concurrency, and then it gives the property of what they do, and it also gives you pictures of each one of these segments. So again, know these well. This is where your sometimes, always, or never questions are going to come from. So again, 10 questions on the quiz. Quiz has a lot of the stuff that is in this warm-up, in addition to the sometimes, always, or nevers. And also, you're going to also have to write an equation of that perpendicular line. So make sure you understand the steps to solve that. So that is it for your quiz review.